Oh yeah, vectors and scalars. Just a quick recap, starting going back over the course again, but I know this is one area where you still struggle, so it's a good place to start. So what is a vector, what is a scalar? Scalars only have magnitude, they only have size associated with them. So scalar quantities, there is no direction involved at all. That's the key part. Okay, we can associate direction with vector quantities, not with scalars. Obviously by the alternate then, vectors have magnitude and direction, scalars don't. If you want a clue, watch Despicable Me. Okay, vector, committing crime in both magnitude and direction. Some different examples of that you can see on my list right in front of you. I've wrote it out for you. So scalar quantities, you can't associate any direction with those. Look at them, think about it. Length, area, volume, speed, mass, density, pressure, temperature, energy, work and power. None of those quantities have got anything to do with direction associated with them. By the alternate vector quantities, displacement, think about it. That's how far you've moved from your starting point. There's clearly direction associated with it. Velocity, acceleration, momentum, force, lift, drag, thrust, weight, all of those things. You may get a question about vector-scalar pairs. If you do get a question about vector and scalar pairs, they're the two that I can think of that might come up on the GCSE. Okay, distance, displacement, they're a pair, they're associated with each other. Distance, displacement. Okay, speed and velocity is the other one. If we get a question, which I'm going to do in a second, we can work out what's going on by using Pythagoras. If our vectors form a 90-degree triangle, if they form a 90-degree triangle, we can use vector and Pythagoras theorem to find our resultant vector. Okay, so here we go then. An example. Jim walks around the supermarket. He travels 15 metres north, then he turns right. He travels 8 metres east, turns right again. He travels 4 metres south, he turns left, he walks 6 metres east. Can we find both the distance travelled and the displacement from the shop door?